the next one is condensation. Condensation is basically, this is when we talk about the Brady's test. Okay, so this is basically known as the Brady's test, whereby the NH3 and its derivatives reacts as a nucleophile and reacts with the carbonyl compounds. It involves the addition reaction followed by dehydration, which is the elimination of H2O to form the carbon. So you would have, for example, if you have a carbonyl compound, a carbonyl organic compound, you react it with the 2,4-dinitrophenylhydrazine, okay, which is the Brady's test, and then you would get. So the condensation with 2,4-dinitrophenylhydrazine or Brady's reagent, also known as the Brady's reagent, okay, is basically a solution of 2,4-dinitrophenylhydrazine in methanol and sulfuric acid. Okay, we usually use this to identify the presence of carbonic compound as a whole. And the observation that you'll usually get is a positive test that gives you a yellow precipitate or an orange precipitate. Okay, you can either choose one of them, whether you want to use a yellow precipitate or an orange precipitate. Okay, so when you want to answer an exam, just choose one of them. It's either you want to choose yellow or an orange precipitate. So if it's a positive test, so there's a presence of aldehyde or a ketone. Okay, remember Brady's test is to identify a carbonyl compound, presence of carbonyl compound. Okay, so whether if it's an aldehyde or a ketone, you don't know. Okay, you have to proceed with the next test, which is the tolerance reagent, in order to find out whether if it's an aldehyde or a ketone. So this is the next test, which is a oxidation of tolerance reagent. So it's also called as a silver mirror test. Okay, this is also another name for the tolerance reagent test, So the reagent that you'll be using is silver 1 oxide in aqueous ammonia. This is the chemical formula for it. So if you have the main point of tolerance reagent, if you have an aldehyde, it shows a positive result. If you have a ketone, it will show a negative result. Okay, so that's how you know whether you have a ketone or an aldehyde in your chemical organic compound. Okay, so what happens in this reaction is that the aldehyde is oxidized to carboxylate ion and argentum is deposited on the wall of the test, also known as a silver mirror form. Okay, so this is what I mentioned earlier, the ketones will give a negative result. Okay, so if you have an aldehyde here, so the reaction will proceed and you will get a carboxylate ion. This is a carboxylate ion. Okay, and then this is you would have a silver argentum, a silver mirror deposited on the wall of the test tube. Okay, if you have a ketone, for example, what happens here is that you would still write it in the same way. It's just that you would write there will be no observable reaction. Okay, so the reaction doesn't proceed. You won't produce carboxylate ion or silver mirror for a ketone. Okay, for an aldehyde, you would produce a carboxylate ion and a silver mirror. For a ketone, you would produce a no observable reaction because there won't be any reaction occurring. Okay, so here is the example of the ketone here. Okay, so you would have a no observable reaction, and so your observation will be no silver mirrors form on the wall of a test tube. Okay, so the silver mirror forms on the test tube wall here if you have an aldehyde. However, if you have a ketone, there will be no silver mirror. Okay, no silver mirror form. That's your observation. Right. Next is the Iodo Foam test. So the Iodo Foam test is basically to detect a methyl carbonyl or also known as a methyl ketone group. So if you have a metal carbonyl present, you would yield a carboxylic ion and the yellow precipitate CHI3. Triiodomethane. Okay, and the reagent that is used is this. It's similar to the ones that you've learned in the alcohol chemical and the alcohol iodo foam test, which is I2 in sodium hydroxide. Okay, so this is a methyl carbonyl. Okay, and this is a methyl carbinol. The differences is that for a methyl carbinol, you must have an hydrogen present. Okay, a hydrogen attached to a carbon that is attached to a hydroxyl group with a methane attached to it. Okay, however, for a methyl carbonyl, you only need a methyl and a carbonyl group attached to a same carbon. Okay, that's it. That's for methyl carbonyl. So what happens is that if you have, so you have a methyl here attached to the carbon that's attached to the carbonyl group here. So that means the reaction will proceed. Okay, so there's a presence of methyl carbonyl causing it to form a carboxylate ion and a yellow precipitate of triiodomethane. Okay, so you have triiodomethane here produced as a side product. So your observation that you'll get is a yellow precipitate. So this is basically your CHI3, triiodomethane. Okay, so this is basically your triiodomethane. So your observation is yellow precipitate. Okay, if you have none, if there is an absence of methyl carbonyl, then you would not have the observation. You basically have a no observable reaction. Okay. So these are some of the extra notes that you have to take note of, which is that if an iodo test followed by an acidification, what you will get is basically a carboxyl group. Okay, you will get a carboxylic acid. So your first step would be an iodo foam test. You will get carboxylate ion as well as the triiodomethane. And then if it's followed by an acidification, which is H3O+, what you'll be getting is that you would have a proton because your carboxylic ion is something like this. So the proton from the H3O+ will balance out the O- here, causing it to form a carboxylic acid group. Okay, so this is the important note that you have to take. If an iodo foam test followed by a H3O+ produce carboxylic acid and yellow precipitate. Okay, so this is the thing that you have to take note for iodo foam test followed by an acidification. Alright, so that's it for today. Thank you. Bye.